All right, this is 1-4 solving absolute value equations. Here's our goal statements. Evaluate expressions involving absolute values and solve absolute value equations. Some vocab to get familiar with. Absolute value is something that you should be comfortable with. It's these little bars, so it's the distance a number is from 0 on the number line. So the absolute value of -2 is 2. The empty set has no numbers in it, and its notation is that 0 with a line through it. We will commonly hear this referred to as no solution or the empty set. Okay. Extraneous solutions, this is the one that is going to be the most important throughout the rest of this, this chapter. There are values of x that appear to make the absolute value equation true, but they do not actually work when they're substituted back in. And a constraint is a condition that a solution must satisfy, like being less than 2. So evaluating absolute value expressions is very similar to evaluating algebraic expressions. We're going to first of all pretend that this says x equals 4, and we're going to evaluate 8 minus the absolute value of 2 times 4 plus 3. We're just plugging in 4 for x in this expression, and now we're going to follow order of operations to solve. So consider order of operations. We want to pay attention to what is in the group first. Absolute value is considered a grouping symbol like parentheses, so we want to handle that first with order of operations. 2 times 4 gives us 8, plus 3 gives us 11. So 8 minus the absolute value of 11. What is the absolute value of 11? It's 11. That's how far 11 is from 0 on a number line. So when we evaluate this, we will get -3. Example 2. Solving an absolute value equation. So when we talk solving absolute value equations, there are two cases that we have to consider. In general, when we take the absolute value of a number, it's going to have two possible cases, the positive case or the negative case. So what happens is we'll remove the grouping symbols, and then we'll set up case 1, which is that x minus 20 equals positive 40. And then we'll set up the second case, which is that x minus 20 equals the negative part of this side, so -40. Those are our two options, and we're going to get two values for x. So x minus 20 equals 40. If we solve that, we get x equals 60. And if we solve the negative case, x minus 20 equals -40, we will get that x equals -20. But we cannot stop here. With absolute value equations, we have the potential to have false solutions that are called extraneous solutions. So whenever we get values for x with absolute values, we need to go back and check them. So let's substitute 60 back in and see if it produces a true statement. Is the absolute value of 60 minus 20, is that equal to 40? Yes. Okay, because we see the absolute value of 60 minus 20 is the absolute value of 40, which is equal to 40. So yes, so x equals 60 is a solution because it works out. Okay, -20, let's check. Does the absolute value of -20 minus 20 equal 40? That's our question. Is the absolute value of -40 equal to 40? Yes. So x equals -20 is also a solution. So both of those work. This is a case where we're going to have no solution. Okay, so something like this, we're following the steps of solving linear equations, and then when we get to the point where the grouping symbol is the only thing on the left side, that's when we separate into the two cases. So first, we're just going to start off keeping that absolute value of 3x minus 2, and we're going to subtract 8 from both sides to get -7. And then now from here is where we'll separate it out into two cases. Okay, but notice right now, we're saying that the absolute value of something is equal to a negative number. That doesn't even make sense. So before we start this problem, we should notice, hey, that's suspicious, okay? So let's separate this out into the two cases. 3x minus 2 equals -7, and it's also possible the other case would be 3x minus 2 equals +7. When we solve for x on the left side, so in the case where it's equal to -7, we're going to get that x is equal to -3. If we add 2, excuse me, it's going to be, I'm ahead of myself, it's going to be -5/3. -5/3. And then over here, we're going to get the x could be equal to 3. So those are our two cases, and we need to plug them back in to see if they're extraneous. So if we plug in -5/3, is the absolute value of 3 times negative 5/3 minus 2, is that equal to negative 7? Is that true? You can plug this in. If you want to do it by hand, that's great. If you want to plug it into Desmos to check, go for it. We're going to get to a point where we see the absolute value of negative 7 plus 8 equals a 1 if we plug into the original. That is not true because well, let me back up here. We want to plug it back into the original, so plus 8 equals 1. Is the absolute value of negative 7 plus 8 equal to 1? No, because it is equal to 15. Okay, absolute value of negative 7 is 7. 7 plus 8 gives us 15. 15 is not equal to 1. So x equals negative 5/3. That is extraneous, so we do not want to include that in our final solution. It appears to be a solution, but it's not. So now let's check x equals 3. Check x equals 3. Is the absolute value of 3 times 3 minus 2 plus 8 equal to 1? That's our question. So we get another situation. 9 minus 2 gives us 7. So is the absolute value of 7 plus 8 equal to 1? No. Again, we end up with 15. 15 is not equal to 1. So neither of these is a solution. So this overall absolute value equation has no solution because both of its solutions that we thought were extraneous. Okay. Last type of example is where we have extraneous solutions. So it's asking us to solve, and we're going to check. So we have two cases to consider here. X plus 10 could equal 4x minus 8. And then for the negative case, we need to be careful and make sure that we put it in, put the 4x minus 8 in parentheses. We could have x plus 10 equals negative 4x minus 8 like that. We got to be careful with that, okay? And then we're going to solve each equation like normal. So x plus 10 equals 4x minus 8. If we solve that out, we're going to end up with negative 3x equals negative 18, so x equals 6. And then if we solve the right side, we're going to end up with 5x equals negative 2, meaning that x equals negative 2/5. Remember to be careful when you're distributing. This is a negative 1. We got to distribute it to both pieces. So this becomes negative 4x plus 8. So these are two solutions, and now we need to check both of them by plugging them into the original. Okay. So we're going to check x equals 6. Does the absolute value of 6 plus 10 equal 4 times 6 minus 8? That's our question. Is that true? And then our second solution that we're checking is x equals negative 2/5. So does the absolute value of negative 2/5 plus 10 equal 4 times negative 2/5 plus, or excuse me, minus 8? Minus 8. We want to make sure to check these very carefully. When we plug and chug, you can use Desmos, you can use your own calculator, it's up to you, but we're going to end up verifying, does the absolute value of 16 on this left side, does it equal 16? Yes. So that means that x equals 6 is a solution. For the other solution though, negative 2/5, we're going to get to a point where does the absolute value of negative 48/5 equal, or does the absolute value of 48/5 equal negative 48/5? No, it equals positive. So x equals negative 2/5. X equals negative 2/5. That is extraneous. So our only solution here is x equals 6. The concept of extraneous solutions happens when we take a false statement and potentially make it true. So we know that 6 is not equal to negative 6. But say that I square both sides, all of a sudden, it looks like these two things are equal. 36 equals 36, but they weren't equal to begin with. So the act of squaring and taking the square root it can mess around with the equal sign, which is why we always got to check for those extraneous solutions. Take a look at the practice, and we'll go over any questions you have in class.